All right, so let's move on to the next part, which is dealing with the spider. As you can see, the spider is moving up and down. Okay, and that is because we are using an animation, uh, which is a powerful dynamic tool in Desmos. Okay, so let's open up the folder for the spider and zoom in a little bit. Okay, so there you can see there's a few circles that make up the cobweb, and there's a few straight lines as well. But what I want to focus on is the spider's movement up and down. Okay, so first of all, let's pause this so that it's fixed. Okay, and I will try to explain how this is moving up or down. Okay, so first of all, a general knowledge of understanding how this ellipse is centered, which is similar to how a circle is centered. Okay, so what I'm going to do to make this hopefully a little bit easier is first of all, get rid of this. Okay, and now you can see that the center is negative 6.8 and 0. Okay, so if I put plus 0.1, it's going to move down 0.1. If I put minus 0.1, it's going to move up 0.1. Okay, so what we wanted to do is move up here, but let it go up and down. So I'll introduce to you, let's go back to its original at 0, a different variable, let's say p. Okay, so you can add p there, and Desmos automatically allows you to add the slider as long as it's not like a normal variable like x or y. So let's add this slider by clicking here. Okay, and let's set these values, say 0 and 2. Okay, so if we press play, you'll see it's moving up and down. Okay, but what's important here is to understand why that is working. Okay, so right now, p is at 0. As you can see, p is equal to 0. Therefore, the center is negative 6.8 and 0. But if I move this to, say, 0.25, the center is now negative 6.8, and it goes up 0.25, which corresponds to the y-axis. As you can see, the numbers are over here. Okay, so that's all that's happening here. So if I press play, it will move up. So what I had to do to make this all work together is give them all the same variable, which was d. I'll pause this one here, but let's look at the other one. See, there's a d here. A d is set over here. Okay, that corresponds to this body part. There's a d over here, which corresponds to these legs, and so on. You can see it's everywhere. I also had to play around with the range, okay, by altering it so that it moves accordingly. And I'll let you play around with it yourself and figure that out. Okay, but the answer is all here anyway. Okay, so just hitting P, that deals with the other body part, which is currently off the screen, but about to come back down. And if I go back to the D, this one controls all these parts right here. Hitting play, you can see it's all moving. And that's the moving spider. Okay, so next we'll focus on the birds. And let's put back the animation on, because maybe you never saw it the first time around, but there's actually some movement here, not only with the bird's wings, but also the bird feeding the baby bird. Okay, so if you notice, there's some movement here, and this is supposed to be a worm. And what that really is, let's open this up and click there. Here it is. Okay, so here's the equation that corresponds to this red worm. All it is y is equal to sine x, but the inverse of that. So you need to understand that by taking the inverse, you just first switch the x and y. So now you have x is equal to sine y. And in addition to that, there's many transformations. And the transformations, as in all of this project, and for anyone who wants to use Desmos, is critically important. So make sure you have a sound understanding of how transformations work. So next, we'll zoom a little out to look at the house that was made. And I just want to pay a little attention to this shading that took place, because although it looks nice and easy, it takes a little bit of effort, not too much, but let's take a look at that. Okay, so I'll click onto this part here, and let's see where the shading is. It's over here. Okay, so what's happening here? Well, once again, similar to the shading that was done with the leaf, there's two parts here, but one problem that is different than the previous one is if I get rid of this x less than 0, it ends up shading all of this, because what it's doing is saying y is greater than or equal to 15. So to understand what that is, just get rid of that. So y is greater than or equal to 15 is everything shaded above y is equal to 15. And let's get rid of this part for now to see that y is less than or equal to 3/4 x plus 30 is beneath here. Okay, so combining them, sorry about that, it is everything here. So this is above y is equal to 15, and this is below y is equal to 3/4 x plus 30. Okay, now the problem is though, we wanted to stop here. So in addition, we had to add a restriction to let all the values of the domain be to the left of the y-axis. So that's x is less than 0, and now only this is shaded. And in case you're getting confused with this part, that is just a separate shading, which is done over here. So I'll hide that, and this is similarly done. Okay, so the last part we'll focus on is what's in space and the moon orbiting around the Earth. So you can see here are a couple equations. Here's the Earth's equations, and the moon has this equation over here. You can tell that this is a circle that is centered around these two coordinates. Okay, now what makes this a little bit difficult is that we want it to rotate. So I incorporated the sine, c, and cos with just some knowledge of the unit circle and understanding how that's formed. So the unit circle, for example, has x squared plus y squared is equal to 1, and each point on the unit circle is cos theta and then sine theta. So using that knowledge, I just thought, well, wait a minute, that will hopefully move it around and multiply it by a much bigger number so that it's not just on a unit circle, but something bigger and further away. So as you can see, there's a c, and that parameter is down here. So now if we just hit this c, you can see it's starting to orbit. And I have a question for you guys. Can any of you come up with why this is 12.56? What is that number? Okay, so I'll give you a little hint. This moon is already making its way almost completely around once. So how does that relate? Well, if you thought about pi in any way, that's very good. Okay, so this is currently set to rotate or orbit around the Earth 2 whole times, which is 4 pi. Okay, so 4 times 3.14 is 12.56. So if you knew that, very good. And if not, that's all good because that is a hard question. Okay, and also you may have noticed that there was a shooting star. So if I press this, you'll see something fly by there. And I'll let you play around with that. And believe it or not, there is a sun here. And I'll let you explore and try to look for the sun and to see if you can find anything else further on in this image. So I hope you enjoy that and hopefully you can make some cool images yourself. You can start easy and small with something just using some straight lines, and as you grow with your mathematical knowledge, I hope to see your images because I know you guys can make some awesome things, as many of my students have proved. So thank you and enjoy creating. A quick thank you to Desmos and their team, or as my students like to call them, Demo, and to Khan Academy as well for this challenge and pushing all of us a little bit further with math. Also a quick thank you to my high school math teacher, Mr. McDonald, who first made us do these kind of images by hand. Clearly left an impression, and here I am all these years later doing it myself. And one last thank you to Sarah Locke for introducing Desmos to me and get me going on this path. She would probably like to say I've learned everything from her, and you know what? She's probably right. So anyways, thank you and have a good one.